Hey guys, welcome back. So let's keep going. In 11 and 12, they're doing the same exact thing, but backwards from 7, 8, 9, and 10. So let's take a look. The area of the whole circle would be if we knew the radius, but we don't. We got to work backwards. And they're asking for us to find the area of the whole circle. So the area of the sector is that portion times the area of the whole circle. Okay. So they're saying that the area of the unshaded is 11.7. So that's pretty interesting, isn't it? So the area of the unshaded, using the same logic, should be what's left over from the 360. So this central angle would be 320, right? So the unshaded is actually 320 slivers out of 360. So I took 360, take away 40 to figure that out. Okay, so that's the portion of unshaded, and we actually know the area of the unshaded. It's 11.17. So now what do we have on our hands? We can solve for the area of the circle by doing double swapsies. So I can move this 360 up here, right? And I can move this 320 down here. Double swapsies. And what do I have? I have the area of the whole circle all by itself on one side. Cool. So let's type that in. 360 times 11.17 divided by 320. All right, so the area of my circle is 12.6. Good job, guys. And if that was in meters squared, this would also be in meters squared. And notice it's a bigger number, which it should be. The unshaded is 11 meters squared, so the whole shaded thing would be bigger. All right, let's look at the next one. This one's not as tricky. This one, they come right out and say the area of the shaded. So the area of the shaded is this portion, 7 over 360, times the area of the whole circle. And that's what they'd like me to solve for. So the area of the shaded is 156.38. And we also know that that's equal to 70 over 360 times the area of the circle. So what do we have here? We can move this 360 up with that, so we can have that multiplied, 360. And we can move this one down there, so move that one. And now the area of the circle is by itself on one side. So let's type that in. 360 times 156.38 divided by 70. So the area of the whole circle is 804.2 yards squared. Now that makes sense. The whole thing would be 800 something if this half is 150. That portion is 150. Cool. All right, let's get to the last ones. These are more similar to the homework from previous. So what do I have here? I have a triangle, and I need the area of this triangle, and then I need the area of that half circle, semicircle. So this is a right angle, so I'm going to make x what I don't know. So I have x squared plus 8 squared has to equal 17. So a little Pythagorean theorem. So let's recopy this. X squared plus 64 is 289. So when I subtract 64 on both sides, I get 225. That's exciting because when I take the square root of both sides, I get 15. 15. So what is the area of this triangle? The area of a triangle is 1/2 base times altitude. Boo! splat. So it's 1/2 times the base, 15, times the altitude, 8. So the area of that triangle is 8 times 15 divided by 2, 60. All right, so the area of that is 60. Now let's find the area of this half circle. So the radius, if the diameter is 8, the radius is 4, and the area would be 4 times pi. So what is the area of this combined shape? It would be 60 plus 16 pi. Now let's look at this one. We have the area of the whole circle. This is like last time. The area that's shaded is going to be the area of the whole circle minus the area of the unshaded. Okay, so what is the whole circle? It's pi r squared, and r is 17. What's the unshaded? Pi r squared, and r is 3. So I have 17 times pi minus 3 times pi. All right, so that's 289 pi minus 9 pi, which would be 280 pi. Oh, so they're saying this whole thing is 10, this whole thing is 10. So what does that mean for us? If I look here, this is a radius, this is another radius, this is another radius, and this is another radius. So the width of the box is 1, 2, 3, 4 radii. That's the plural of radius. And the height of the box is 4 radii. So to figure out one radius, it would be 10 divided by 4. So let's figure out what is 10 divided by 4. We get 2.5. So 2.5 plus 2.5 is 5, and another 2.5s, that makes sense. Okay, so what's my formula? Well, the area that's shaded here is the area of the whole minus the area of the unshaded. So the whole thing is a square, which is base 10 times height 10. The area of the unshaded would be pi r squared, but we have 4 circles, so we're going to have to multiply them by 4. So we get 100 minus pi times 2.5 times 2.5 times 4. So I get 100 minus 25 pi. Good job, guys. All right, last one. This one's kind of tricky. It says, what if you had a sprinkler system? I'm going to actually draw a smaller picture. And this was 40 feet, right? And this is the area that you were sprinkling with your lawn. And that was 40 feet at the angle 130. Then they said, what if we double the radius? So if we double the radius, we have another 40 feet. So that would make for a total of 80 feet for the radius, right? And that would drastically increase the amount of grass that would get sprinkled, or area that would be seen by the security camera. This is the whole new area there. So it says, a new security camera installed at a position that doubles the radius. How does this affect the coverage area? So the coverage area before, right, was this portion of 360 times the area of my whole circle. So what is the area of my whole circle? Well, if the radius is 40, the area of the whole circle is 40 times pi. So that's 1600 pi. So this is the coverage before, right? Now, if we expanded the coverage, now my radius is 80. So my area of my whole big circle now is 80 times pi. So after the expansion, because it says, how will this affect the coverage area? You still have 130 over 360, but now my area of my big circle is much, much bigger. It's 6,400 pi. So when I compare this, I notice that this one is 4 times bigger. I can show you how to compare this. If you take 6,400 divided by 1,600, you get 4. So the new coverage area is 4 times larger. You might be thinking, how's that possible? We only doubled it. We didn't quadruple it. But think of it this way. You increased the radius in the x dimension, right? And in the y dimension. So both in the x and in the y. So when you increase a radius, it actually quadruples the area. Pretty cool. Thanks for joining us, guys.